Good morning students, this is Latif sir. In this video I am going to start the chapter 6 of class 10 chemistry. The topic is electrolysis. Okay, I have marked the syllabus here, you can see, and according to the reduced syllabus for board exam you have to read the entire chapter. Nothing is reduced from this chapter. Okay, complete chapter is given, you have to read the complete chapter. So the topic is electrolysis. Electrolysis. What is electrolysis? Electrolysis means electro means current and lysis means separating. Okay. So if chemical change is carried out using electric current, then the chemical change is known as electrolysis. Okay. If a chemical reaction is carried out using electric current, then the chemical change is known as electrolysis. Okay, for example, if you pass electric current through water, then you will see that water will dissociate into into high H plus and OH minus, and finally you will get hydrogen gas and oxygen gas. Okay, so if you pass electric current, then you will get, if you pass electricity through water, then you will get hydrogen gas and oxygen gas, and this is an example of electrolysis. So electrolysis means chemical change by passing electricity or electric current is known as electrolysis. Okay, so generally we know that metals are conductor of electricity because metals are good conductor of electricity. Metals like copper, gold, iron, aluminium, these are good conductor of electricity because they have huge number of electrons, free electrons, and they are conductor of electricity. And generally non-metals are non-conductor of electricity because they do not have free electrons. But there are some, okay, so due to presence of free electrons, metals are good conductor of electricity. They can conduct electricity due to presence of free electrons, and these free electrons can flow on the surface of the metal. But non-metals or insulator do not possess such mobile or free electrons, and they are bad conductor or non-conductor of electricity. And there are some chemical compounds, like NaCl, like concentrated sulfuric acid, like sodium hydroxide. So there are some chemical compounds, although these are not pure metal, but they can conduct electricity. Okay, so some compounds conduct electricity in aqueous state or in molten state, not in solid state, remember that. And on passing electric current, these chemical substances dissociate into oppositely charged ion, and due to presence of oppositely charged ions in aqueous solution or in liquid state, this chemical compound can conduct electricity, and these chemical substances are known as electrolytes. Okay, so chemicals compounds like NaCl, H2SO4, NOH, which conduct electric current in molten state or in aqueous state, not in solid state, remember that. And these chemical compounds are known as electrolytes. An example of electrolytes are HCl, NaOH, NaCl. There are lots of electrolytes are there. Okay, and again I am telling, these electrolytes dissociate into oppositely charged ion in aqueous solution, and due to presence of these mobile ions, cations and anions, electrolytes can conduct electricity. So what is the basic difference between metallic conductor and electrolytic conductor? Metallic conductor can conduct electricity due to presence of free electrons, while electrolytic conductor can conduct electricity due to presence of oppositely charged ions. But many chemical compounds cannot conduct electricity in aqueous solution or in liquid state, because they do not have any ions in aqueous solution or in liquid state, and these chemical substances are known as non-electrolytes. Okay, like sugar solution do not have any any oppositely charged ions. That's why sugar solutions are non-electrolytes. Okay, but NaCl solution, NaCl in aqueous solution of sodium chloride, NaCl dissociate into oppositely charged ion cation, that is Na plus and Cl minus, and due to presence of this Na plus Cl minus ion, they can conduct electricity. Okay, generally electrolytes, remember that generally electrolytes are ionic compound or electrovalent compound which can dissociate into ions. And some polar polar covalent compounds like HCl, like H2, so forth, they can also conduct electricity because they can also dissociate into ions. Okay, in aqueous solution. And non-electrolytes are generally covalent compounds are non-electrolyte. Okay, so one difference between metallic conductor and electrolytic conductor is given. Metallic conductor, in I have told, in metallic conductor can conduct electricity due to presence of free electrons, but electrolytic conductor can conduct electricity due to presence of oppositely charged ions, that is cations and anions. Due to presence of cations and anions, electrolytic solution like copper sulfate solution like NaCl solution can conduct electricity. Okay. So this is the main difference. Okay, and in metallic conductor there is no chemical change. Okay, but in electrolytic conductor there is some new substances are formed at two electrode, and so electrolytic conductor in electrolytic conductor chemical reactions are taking place, but in metallic conductor this is a physical process, not no chemical process. Okay, now see definition and example. Some term definition of some term is given here, like electrolysis. I have told what is electrolysis. It is the process of decomposition of a chemical compound in aqueous solution. Electrolysis is the process of decomposition of a chemical compound in aqueous solution or in molten state. Remember that, not in solid state. Electrolysis, it is the process of decomposition of a chemical compound in aqueous solution or in molten state accompanied by electric charge, by accompanied by a chemical change by using direct electric current. Okay, so electrolysis is the process of decomposition of a chemical compound in aqueous solution or in molten state accompanied by a chemical change by using electric current. So chemical change using electric current is known as electrolysis in simple word. And electrolytes, I have already told, electrolytes are chemical compounds which can decompose in aqueous solution or in molten state and conduct electricity. Okay. So electrolytes are compound which either in aqueous solution or in molten state allow electric current to pass through them. And electrolytes are molten salts or solution of salts in water solution or solution of acid or alkalis. There are lots of electrolytes are given. Okay, example of electrolytes: strong electrolyte, any strong acid like H2SO4, HNO3, HCl, any strong base NaOH, KOH, any strong salt NaCl, copper sulfate, Pb, Br2. These are strong electrolyte. And electrolyte are two type: strong electrolyte, weak electrolyte. Strong electrolyte ionized completely almost, and weak electrolyte ionized, not ionized completely. Okay, so one difference between strong electrolyte, weak electrolyte is given. Strong electrolyte can dissociate into ions completely. Okay, and they can conduct more electricity in aqueous solution or in liquid state. But weak electrolyte, they dissociate partially. Okay, weak electrolyte dissociate partially, and strong electrolyte dissociate almost completely. Therefore number of ions in strong electrolyte will be more than number of ion in weak electrolyte. Okay, in case of a strong electrolyte, this solution contain almost only free mobile ions, cations and anion. But in case of weak electrolyte, they as they dissociate partially, their solution contains ions as well as some neutral molecules. Okay, in a strong electrolyte, strong electric current will pass through the solution, and in case of weak electrolyte, weak electric current, small weak electric current, electricity will pass. Example of strong electrolyte: any strong acid like HCl, and any strong base like NaOH, KOH, salt like NaCl, PbBr2, copper sulfate. These are strong electrolyte. And weak electrolyte, some acid, weak acid like carbonic acid, acetic acid, these are weak acid and these are weak electrolyte. And weak base like ammonium hydroxide, NH4OH, calcium hydroxide, CaOH whole twice, ammonium carbonate, lead acetate, all these are weak electrolyte, example of weak electrolyte. And non-electrolyte, the substances which do not conduct electricity in aqueous solution, okay, because they do not ionize or do not dissociate in aqueous solution, and these are known as non-electrolyte. Okay, example of non-electrolytes are sugar, alcohol, cane sugar, carbon disulfide. These are non-electrolyte. Here some electrolyte and their dissociation also given in this table. Okay, some acidic strong electrolyte and their dissociation also given. You can see strong electrolyte like HCl can dissociate into ion H plus and Cl minus ion. Nitric acid can dissociate into H plus 3 minus ion. Sulfuric acid can dissociate into H plus and SO4 2 minus ion. And weak electrolyte like acetic acid can dissociate into acetate ion and H plus ion. Formic acid can ionize in H formate ion, that is HCO minus and H plus ion. Okay, so dissociation of some acid and electrolytic dissociation of some bases also given. Some strong bases like NaOH, KOH, they dissociate into positively and negatively charged ion. For example, NaOH dissociate into Na plus OH minus ion, KOH dissociate into K plus OH minus ion. Okay, some weak electrolyte like ammonium hydroxide which dissociate into ammonium ion and hydroxide ion. Okay. So this dissociation of different salt, different acid you have to read. Okay, and which ion they will produce in aqueous solution. For now, dissociation of salt, strong electrolyte like lead bromide, PbBr to dissociate into Pb2 plus ion and Br minus ion, 2Br minus ion in in molten state. Similarly, silver nitrate dissociate into Ag plus ion, Na3 minus ion. Okay, some weak salt like ammonium carbonate which dissociate into ammonium ion, that is NH4 plus ion, and carbonate, that is CO3 2 minus ion. Lead acetate, strong, it is also weak electrolyte, weak salt. Okay, now see what is electrolytic cell. Electrolysis of an electrolyte is carried out in a special type of instrument which is known as electrolytic cell. It is also known as voltmeter. Voltmeter, it is a vessel, it is a non-conductive vessel containing two electrodes. One is known as cathode, another is known as anode. And these two electrodes immersed in a solution of electrolyte. These two electrodes, generally electrodes are made up of metal conductor. Sometimes non-metallic electrodes are also used, okay, in electrolytic cell or voltmeter. And these two electrodes, that is cathode and anode, immersed in a solution of electrolyte used to bring about a chemical reaction. An electrolytic cell require an outside source of electric current. Generally DC source of electric current is used, direct current is passed. Okay, and in this electrolytic cell direct current is used, and this electrical energy is converted into chemical energy. Okay, you have to pass electric current using a battery, and here you have to take electrolytic solution, and you have to dip both the cathode and anode. You have to dip the cathode and anode. You have to immerse the cathode and anode in the electrolytic solution, and this entire arrangement is known as electrolytic cell or voltmeter. And if you pass electric current through the solution, electrolytic solution, you will see there will be some chemical change. Okay, you will get two different product on cathode and anode. Okay, electrodes, I have told electrodes. Electrodes are generally metal plates or metal wire, or sometimes non-metal like conductor non-metals like uh, graphite rod or gas carbon, and these are good conductor of electricity, you know that. That's why some non-metals like graphite, gas carbon, these rods also used as electrodes. Electrodes are generally are conductor of electricity. Okay, anode and cathode. Anode is the electrode connected to the positive terminal of battery. Okay, the metal plate or non-metallic plate, which is a conductor of electricity, which is connected to the positive terminal of the battery, is known as anode. So anode is positively charged electrode, and cathode, the electrode connected to negative terminal of the battery, is known as cathode. So cathode is negatively charged, anode is positively charged, and cathode is negatively charged. Okay, and on passing electric current, the anions from the electrolytic solution goes towards anode, because anode is positively charged. Anion migrates towards anode, and cations migrates towards cathode, because cathode is negative and cations are positive. So cation migrates towards cathode when you pass electric current. Okay, so on passing electric current through the electrolytic solution, you will see that the cation will migrate towards cathode, negatively charged electrode, and anions will migrate towards anode, that is positively charged electrode. Okay, so difference between cathode and anode given. Okay, cation migrates toward cathode, and therefore cation accepts some electron from cathode, negatively charged electron, and the cation reduced. Okay, so at cathode, reduction reaction take place. Okay, at cathode, reduction reaction take place at cathode, and anion migrates towards anode, and therefore anion loses some electron to the anode, and anion oxidize. So oxidation reaction take place at anode. Okay, so this is the difference between cathode and anode is given here. You can see. Cation, anion, you know that cations are positively charged, anion are negatively charged, and oxidation definition, the terms oxidation, reduction, you have already studied in lower class. Here in electrolysis, you have to remember the definition of oxidation in terms of electron. Okay, oxidation means removal of electrons, or losing of electron is known as oxidation. Okay, so oxidation is the process in which an atom or an ion loses electron. Okay, for zinc, when zinc loses 2 electron, it forms Zn2 plus. This is oxidation. You have to remember that definition in terms of oxidation, in terms of electron, in case in this chapter. Okay, and reduction means gaining of electron. Okay, so reduction, it is the in the electronic concept, reduction means the process in which an atom or an ion gain electrons. Okay, in this chapter, definition of oxidation and reduction, you have to remember in terms of electrons only. Okay, and the electrolytic process, electrolytic reaction or cell reaction, is actually a redox reaction, because oxidation reaction is taking place at anode and reduction reaction is taking place at cathode. Both oxidation and reduction reactions are taking place at 2 electrodes. So so the cell reaction is actually a redox reaction. Okay, now see theory of electrolytic dissociation. Arrhenius theory. Okay, according to Arrhenius, an electrolyte on dissolving in water, it dissociates into free mobile ions, that is positively and negatively charged ions, that is cation and anions. Okay, and all these ions carry an electric charge, and they are responsible for the flow of electric current through the solution. Okay, and the number of positive charge in the solution, in the electrolytic solution, the number of positive charges equal the number of negatively charged in the solution, and thus the solution is electrolytic and thus the solution is in electrolytic equilibrium because total number of positive and negative charge in the solution is equal. Okay, and now see conduction conduction in compounds. I have already told this one. Some chemical electrolytic compounds, electrolytes, they can conduct electricity in liquid state or in molten state, because in liquid state and molten state they can dissociate into oppositely charged ion, but in solid state the oppositely charged ions are tightly held together by strong electrostatic force of attraction. Okay, in solid state the ions are not free. That's why in solid state in solid state these compounds do not conduct electricity. For example, sodium chloride cannot conduct electricity in solid state because in solid state the Na plus and Cl minus ion are very tightly attached together due to presence of strong electrostatic force of attraction. But in liquid state Na plus Cl minus ion are free, so they can conduct electricity. Okay. Now characteristic of electrolysis. Now see the characteristic of electrolysis. So on passing electric current through the solution, cation migrates towards cathode and anion migrates towards anode. And anion I have told cation migrates towards cathode and reduce by gaining electron from cathode, and anion migrates towards anode and loses some electron at anode and oxidize. Okay, and only hydrogen gas and the metals are liberated at the cathode, and remember this point. At cathode only hydrogen gas and metals are liberated at cathode, and hence they are called electropositive element. And at anode only non-metals are liberated at anode, and they are called electronegative element. And next point, the mass of substance produced at an electrode during electrolysis is proportional to quantity of electricity passing through the electrolyte. If more amount of electricity is passed through the solution, then you will get more mass of the substance at the electrode. If small amount is current passed, then you will get small amount of substance on the electrode. Okay, this is according to Faraday laws. Okay, so I have told before some time, I have already told the process of electrolysis is a redox reaction, because both oxidation and reduction reaction taking place at two electrode. At cathode reduction reaction is taking place, at anode oxidation reaction take place. Okay, if you pass electric current through NaCl solution, if you pass electric current through sodium chloride, molten sodium chloride in molten state, it dissociate into Na plus and Cl minus ion, and on passing electric current, Na plus ion migrates towards cathode, cation migrates towards cathode, and it's reduced by gaining one electron. Okay, and so at cathode you will get sodium metal, and at anode the reaction is Cl minus ion migrates towards anode and loses one electron, and it oxidizes to chlorine gas finally. So on passing electric current through NaCl, molten NaCl, you will get sodium metal at cathode and chlorine gas at anode. Two different product you will get at two electrode. And one more point, important point is given. You can see the alternating current, AC current in electrolysis. You have to use DC current, direct current. Alternating current does not cause any chemical change when passed through and electrolytes, and therefore does not help electrolysis to occur. So for electrolysis you have to pass only direct current. Okay. Now electrolytic dissociation, it is very simple. Dissociation of ionic compound in aqueous solution. Dissociation of ionic compound in liquid state or in aqueous solution into oppositely charged ion is known as electrolytic dissociation. Okay. So electrolytic dissociation, the term is used for ionic compound only. Okay. And for ionization, this term is for polar covalent compounds. Polar covalent compounds, they can also ionize in oppositely charged ion. Okay, so the process by which polar covalent compounds are converted into ions in water solution are known as ionization. Actually both terms are almost same. Ionization is term is used for polar covalent compound and dissociation is used for uh, ionic compound. So, and thing is same, both in both case the substance, the compound is the compound is converted into ions, oppositely charged ion. Okay, so see the difference between ionization and dissociation. Ionization it is the formation of positively or negatively charged ion from molecules which are not initially in ionic state. This is ionization. So in case of polar covalent compound, ionization term is used. And dissociation, this is a separation of ions which are already present in an ionic compound. So in ionic compound, for ionic compound, the term dissociation is used. And ionization, polar covalent compound show ionization, that is HCl, H2, H2CO3, NH4OH. These are polar covalent compounds shows ionization. And electrovalent compounds show dissociation. Like KCl, dissociate into K plus and Cl minus. Okay. And next day I'll discuss about electrochemical series. Thank you, students.